can do that. Demux is basically just a demultiplexer. It basically splits a stream into multiple substreams. Metering, basically just measuring the streams. Throttling, so if you need to basically limit the amount of data that's transferred, so if you want to say only 1 megabit per second, you can do that. Or if you want to base it on records, you can do that as well. You could say only transfer 100 records per second or something like that, then you can do that with the throttling. There's remove duplicates, sequencing. So sequencing basically just pulls together different input streams into a single stream. Aggregation is basically just like SQL aggregation, so count, average, count, max, that kind of thing. Now async is a little bit different. I know I put this all in the transformation slide, but it's more, async is basically how you add threading. So you can add an async reader, async writer, and it'll basically perform that operation in a separate thread. You can just tell it how big a buffer to use. That's about it.
How do you get those results back
into the main?
Yeah.
So you don't really have to do anything. So just like those examples I showed you before, if you have like a CSV reader and let's say it's pulling from a network or something that's taking a while, then you can tell it to buffer as fast as it can. So the way you do that is you just create a new async reader, pass in your original reader, so CSV or database or what have you, and then whenever you pull from the async reader, it'll just pull from its buffer.
Okay.
If it can't, then it'll just actually pull from the underlying stream.
Async step, it lets it go as fast as it can.
Exactly. Yeah, I mean, some frameworks, they basically add buffers and threading at every level, but I think that's a bit wasteful from a context switching point of view, so I just made it so that you can specify when you want to include threads.
This is mostly pure, like, pipeline. When something at the end of the pipeline wants data, it pulls, and it pulls all the way through
Exactly.
the nearest async step.
Exactly, yeah. Yeah, you're right, exactly, it's a pull model. So in the case that you want it to be a little more efficient, because there's some step in the process that's a little slower, then yeah, you could put an async reader or even an async writer, and you can kind of connect them together. So, another one is that's not really a transformation is a JDBC multi-writer. It's a little bit experimental right now. It writes to multiple connections simultaneously, but yeah, I just put it here so you can see that. And then there's the multi-writer, which writes to multiple streams at once. So. Okay. Diving a little bit deeper, basically all the transformations are implemented as data readers and writers, like I mentioned before. The main difference is that they tend to extend the proxy reader and proxy writer. So if you're familiar with Java I/O, Java I/O's got filter input stream and filter output stream, I think. So this is basically kind of like that concept. Basically there's a nested data reader or nested data writer, which is the real target. And then there's a protected intercept record method that you can implement. You can certainly implement the read method, but this is probably the easiest thing, and perform whatever operation you want if you're planning to customize it. So, for example, we've got the filtering. I mentioned this filtering, validation, and so on, and those are all implemented, as I said, as subclasses of the proxies. So, same with the async. So just delving a little bit into the code now. So this example basically takes data from a CSV file and it converts it to a fixed width file. But in the middle it does a whole bunch of transformations. So the first line creates the new CSV reader, and it basically says, the field separator is a pipe, so it's not really CSV, it's delimited, but everyone looks for CSV, they don't look for delimited, so that's why it's called CSV reader. Next, it says that the field names are in the first row. The second bit here, where we create the new filtering reader. So what this is doing is basically saying that look for a field called email, and if you find it, look for a value that's a regular expression. In this case, ends with .com, and those are the records that we want to keep. So the filtering reader basically just matches records that matches the pattern, and just keeps them. Everything else gets discarded. So that line grabs all the records where the email ends in .com. The next line basically says that these are the only fields that I want. I only want the email field, first name and last name fields. That's it. Everything else gets discarded. And the next line, the transforming reader, basically just does a rename. So renames F name and L name to first name, last name. These could be combined because you can see that they're both just operations on a transforming reader. I just added it like this for readability. That's about it. And the second last section here now creates the fixed width writer. And this basically, you give it the target file name. You say that it's got the 3 fields. So I want them to be 64 characters, 20 characters, and 20 characters. The field names are going to be in the first row, and then it writes them. By default, the padding is space, but you can change it globally or on a field-by-field basis. So.
What does it do when the data won't fit the field?
Yeah, that's a good question. The question is, what does it do if the data doesn't fit? For example, I think emails are like 254 characters. That's like the official length. So obviously that might not fit in a 64 character field. So it'll either truncate it or you can throw an exception.
Okay.
Yeah. So.
In case of email, probably want an exception.
Yeah, other things, exactly. Yeah. So that's up to you, right?
So is that field by field when you're setting it up, like when you're configuring the CSV writer? Sorry, the fixed width writer?
In terms of the exception?
Yeah.
Unfortunately, right now it's global, but that's a good idea. So
What was the question?
the question now is it a field by field setting that lets you decide if it should truncate it or if it should just throw an exception? So I said it's global, but it's a good idea, so we'll make it field by field. All right. Thanks for that suggestion, actually. Okay, so the next section is actually looking at actual data conversions. So data conversions are very much like transformations, but it's just a special case, that's all. Pretty much everything you can do in a transformation, everything you can do in a data conversion, you can do in a transformation. It's just easier to lump them all together. So we looked at the transforming reader before. And one of the things you can pass into the transforming reader is a basic field transformer. And that basically has methods to do conversions from whatever to dates, numbers to whatever, strings, string to whatever, whatever to string, null to whatever, does some rounding. There's also some string manipulation in there. So insert, append, prepend, substring, padding, replace ranges, and so on. And you can also add your own. And the main thing I'll point out about this is that if you guys are familiar with the Fluent interface way of writing APIs. Okay, so Fluent interface, basically, when you call a method, the method returns this, so that way you can keep calling methods, right, without having to get a reference. And if you're also, so what that does is it lets you just basically kind of declare what operations you want to perform on a particular field, and then once it goes through the transformation, those will get applied. So here's just a brief example. So you can say you plug this into the XML example we had earlier, for example. So we create a transforming reader that wraps the original reader, and we say we want to perform some transformations on the ID field, and all you want to do here is convert strings to long. That's about it. The next field is price. So if you get a null to value means if there's a null value, just convert it to 0 string, and then convert all the strings to doubles. So at the end of the day, that price will be turned into a double. So. And the final transformation is just a date. Pretty simple stuff. It just takes a date field, converts it from a string to a date using the pattern from Java's simple date format. And then if there's a null, just convert the null to today's date, just a new instance of date. So, right. And order matters. So these things are getting basically applied in the order that you define them here. So if you switch them around, then strange things may happen. So.
Just a question for use of these. If is a transforming reader and all of the transformers, are they thread safe so I can instantiate one and just keep reusing it for many different readers?
So, sorry, you're asking if the transforming reader is thread safe?
Yeah.
So the way I would answer that is it's like Java I/O, right? So Java I/O, is it thread safe? I would say no, because it depends on the underlying stream. Like, I mean, if you have a database connection, that'll be thread safe, but if you have other things and you try to use them in multiple threads, it's probably not going to do what you want. So typically, if you need multi-threading, then you should use the async reader and writer. But I wouldn't try to take something and use it, like create an instance of basic field transformer and try to use that in multiple threads.
Right, so you would probably create a new one each time rather than saying,
Yeah.
oh, this is this kind of field transformer.
Right, and I mean, objects are cheap, right? So we have gigabytes of memory. So like, it's not the days where, you know, we're trying to fit things into a kilobyte. So I would say just instantiate it.
Okay.
And it'll also save on like memory, potentially memory leaks and things like that as well. So, okay. Okay, so we just blazed through basically, you know, a high level of what's in data pipeline. The next section really goes into customization, so that's where we'll look at more code. Do you guys have any questions before we move on?
I have a question. What's the situation with exception handling? Can you set like a policy about, let's say I'm processing a big chunk of data, big batch of data. Something happens within that batch.
Yep.
Can I set whether I continue, whether I break, how I identify it, where it broke?
Yeah, so you saw that we were using, let me just go back a couple steps. So at the bottom, we've got like the job template, and that's really what governs the transformation. So there, we're using the default and just taking a reader writer, but you can actually do what you're asking, which is you can decide whether to continue on error or, yeah, definitely, yep. So, okay, any other questions before we go on? Nope. Okay. So in terms of customization, we'll look at customizing formats, transformations, data conversions, filters and validations, which are really the same thing, and lookups. So in terms of creating your own data formats, basically all you do is you subclass data reader and data writer. You implement the read implementation method and the write implementation method, and obviously open and close as well. So here's an example. Can you guys actually read that at the back? Yep. Okay, good. I was not sure if it would be too small. So there's a lot of code here. On the left side is basically a new reader which just reads property files, like, you know, resource bundles, right? In this case, it's got a field reference to the properties file, and then something which is the keys, which we'll get to. And there's one constructor right now which just takes in the properties. But if you're creating something more production ready or reusable, then you'd probably want to take in an input stream and a file as well. So the next method is the open method, and all this does here is basically grabs the property file, the property that came into the constructor, and just starts getting the keys from it. That's about it. And then the close method just sets it to null. So the guts of it is the last method, which is the read implementation. So this looks at the keys, and it just checks to see if there are any more keys, and if they're not, then it returns null. So that's the end of the stream. Basically what it does now is, if there are keys, it'll try to get the next key, and also get the next value. It'll create a new record, and then put the name and the key and the value into the record, and then return it. So that's about it. How you might use something like this is in the top right-hand corner. Let's say you're reading in some properties. You can create the property, load it, create the Java util properties, load it from a file, and then pass the properties into your properties reader. And then you can create a writer, which is basically a stream writer. All it does is writes records to